Hi, I'm Bo Tao, and this is my literature review. This is a paper I found regarding VR, which is I found kind of actually very interesting. So it's about occlusion management in VR. It's a comparative study. So let's start. So basically, in the intro part, the author admits that the VR is very cool, but if you want to explore VR, there are many constraints. If you, for example, in real life, when you want to play VR, you gotta watch out for the furniture and other stuff that may cause danger to you while you are unaware of real life situation. But the real world challenges is also exist in VR too. For example, oh, there's something wrong with my slides. So, for example, the when you play in VR, there are many things like you can uh, the stuff might block each other. For example, you are doing a like a shop application, and in the shop application, the shelves, because there are tons of shelves, the shelves could block each other, which could force user to move extensively to check the occluded area. And a similar scenario, like in the parking garage, tons of vehicle and walls and the poles that could limit the visibility, so making the exploration very difficult. So the occlusion management techniques, these can largely help to alleviate these such difficulties and make the user experience towards very complex VR world more native, natural, and intuitive. So background. So because walking, the author mentioned walking is the most natural and intuitive way to explore the virtual world, but the obstacle could be a problem when exploring complex VR problems. So the author, in the background, the author basically introduced lots of current way in the industry to solve the obstacle problem. These are interactive navigation, which is the traditional approach where user can find regions of interest through navigation. It's like through navigation, like augmented with visual hint. The top view visualization is they can provide like a bird eye view of the scene. Very useful for 2D, 3D, 2.5D scenes, but it's less effective for scenes with multiple horizontal layers of occlusion. There are also X-ray visualization, which is render occluders semi-transparently, making it easier to view areas behind them, which is the stuff is like just opaque. It's like you can just see through it. But the stuff is there. You can see something is there, but the texture is transparent, so that you can just directly see through it, see the area behind it. So very effective in scenario with predefined occluders and ROIs. And there are cutaway visualization, which is removing the occluders to expose ROI, but this can lead to a loss of context. That could be a problem. There's explosion methods. So this method reduces occlusion by moving parts of the scene away from each other, which just if that scene blocking your way, delete it, something like that. And there's like multi perspective visualization, which is use non-traditional camera models to integrate multiple viewpoints to mitigating occlusions and increasing information visibility. These are the current methods in the industry that has been applied. So basically, for the occlusion management methods in this paper, the author uh, discovered these three methods, which is top view visualization, X-ray visualization, multi-perspective visualization. So just as I said before, top view we say is a orthographic projection from above. Oh, sorry, I didn't say that. Showing an overview of the scene, which is like you can see from the ceiling to the ground. Is that perspective? X-ray depth peeling approach that renders occlusion layers semi-transparent. Like I said before, multi-perspective. There are different cameras that you can allow you to see it from different perspective. These are the methods. So the experiment design. So they use the HTC Vive Pro system, and before they start the experiment, just like everyone who want to do research project, you have to do tons of like not warranty. It's like a warning or like do something to ensure the participant safety. In this experiment too, the participant completed the simulator sickness questionnaire before and after the experiment to assess any discomfort caused by the VR experience. You don't want to like, oh, today I participate in an experiment and I puked everywhere because I have motion sickness. You don't want that. So okay, they are very caring. And so basically they tested two scenarios. One is the participant were tasked with finding items in a virtual supermarket, and the second task is locating people in a virtual parking garage. Remember what I said before, that it's like these are two scenarios, but the author gonna test that in these three methods that I mentioned in my last slide. And besides that, the participant also tested on spatial awareness and depth perception to further understand the impact of each visualization method. So after experiment evaluation, there are two metrics. One is the performance metrics. So for the performance metrics, they measured the task completion time, total distance traveled, and total head rotation. So the task completion time, just like you said, is how long it takes for a participant to complete the task. It represents the efficiency, the total distance traveled, the amount of physical movement required by participants to complete the task, and there are also total head rotation. Measuring the total head rotation helps in understand the user's interaction with the environment and the ease of exploring the VR scene using each method. So you can get all these three as how effective these methods is doing. Like yeah, because a very efficient method will make you complete it as very fast and very efficient. You don't need to uh you don't need to like go there and go that and find that the first half of the movement is completely waste of time. That won't happen, and you won't be like looking at left right over and over. That's not effective, and that is also that's the performance metrics of the evaluation. There are also user experiment, which is like more about humane perspective. This one is for example, they also measure the spatial awareness, depth perception, simulator sickness. The spatial awareness is evaluate how well participants could maintain their sense of direction and location within the virtual environment using each visualization technique. Because some people are born with less sensitive the sense of direction, and that could also somehow affect the experiment result. And there are also depth perception, which is ability to judge distance in the VR environment. Sickness, just I said before, evaluation of any discomfort or disorientation experienced by the participant. You don't want this type of method to be like could very easily make the participant feel nauseous. That is not effective way. So the result. So basically, from result, long story short, the top view visualization find out to be the most helpful one to understand the overall layout, and it's the least helpful one to find specific item and target. And the X-ray visualization is find to be performed very well. Sorry, is there a typo? Perform very well in simple scene, but it is very less helpful in complicated scene like supermarket. So it's more good for simple scene. The multi-perspective visualization is mostly helpful to navigate in most cases. It turns out to be the most flexible one. So conclusion. So basically, compared to other methods, the top view and X-ray multi-perspective visualization demonstrates among all these, the multi-perspective visualization, that one demonstrated much better performance in assisting navigating in VR. And the experiment found that none of these methods have a significant impact of sickness on test subject, which is great. And the limitation is basically the author mentioned that this experiment is conducted under a strictly controlled environment. In the real life circumstances, the circumstances may vary, and the interface that the experiment used is complex compared to a normal system. So these are the stuff that the authors think they can improve in the future time.